Dear students, welcome back to the second part of my video series regarding the numerical. Without wasting time, let me go to the first problem. By using the method of dimension, check the accuracy of the following formula. T is equal to R H rho G divided by 2 cos theta. And where T is the surface tension, H is the height of the liquid, rho is the density. Rho is the density and G is the acceleration due to gravity. And cos theta, as you know, it is an angle. So how to solve this question? It's very simple. We will compare the dimensions of LHS and RHS. So first of all, what is the surface tension? So surface tension you may know from 9th class, that is the force per unit length which is basically acting on the surface of liquid in order to reduce its area. And that's why most of the liquids in space will be in a spherical shape. Surface tension T I am writing. Surface tension T is equal to force per unit length. So don't be confused with this formula with the force per unit area, that is for pressure. Okay, so anyway, the dimension of force is M L T raised to minus 2 and dimension of length is L. L cancelled, so finally we have M T raised to minus 2. Okay, so LHS will be M T raised to minus 2 in the above equation. So M T raised to minus 2 is equal to what? The dimensions of the rest of the quantities RHS, that is R H rho G divided by cos theta. We can write like this. So here we want to find the dimension of each quantity. So R is the radius of the tube. So anyway, radius will be in terms of length. So dimension of length is L. So it will be L, and H is the height of the liquid column. So that will be also in L, and rho is the density. So density has a dimension. Density is basically mass per volume. So mass has a dimension M and volume has a dimension L cube. So that will be M L raised to minus 3. So I am writing here M L raised to minus 3 as the dimension of rho. Next, G. G is the acceleration due to gravity. So acceleration due to gravity has the same dimension of acceleration. So L T raised to minus 2 is the dimension of G. So I am writing L T raised to minus 2 divided by 2 cos theta. 2 is a constant and cos theta, it is an angle. As you know, angle does not have any dimensions. They are dimensionless quantity. So simply I am writing 1. So which is equal to L into L will be L square, and that L square into L here, that will be L cube. So I am writing L cube into M. I am writing it as a M, then T raised to minus 2 into minus 3. So this minus L3, L raised to 3 and L raised to minus 3 and L raised to plus 3 will be cancelling. So finally M T raised to minus 2 will be the dimension of the entire quantities of RHS. So here in LHS it will be M T raised to minus 2. So dimension of LHS equal to the dimension of RHS. So hence it is proved. Okay, let me consider another question. A book with many printing errors contains 4 different formulae for the displacement y of a particle undergoing a certain periodic motion. That is, y is equal to a sine 2 pi t divided by t. Second, y is equal to a sine vt. And third, y is equal to a by t sine t by a. And fourth, y is equal to a root 2 sine 2 pi t divided by t plus cos 2 pi t by t, where a is the maximum displacement of the particle, v is the speed of the particle, t the time period of motion. Now our question is, rule out the wrong formula on the dimensional grounds. It's a very easy question. This is from the NCERT question. Y equal to a sine 2 pi t by t. This is, so we want to check whether the formula is correct or not. So it is already given y is the displacement and a is the maximum displacement of the particle, that is the amplitude. When you consider a motion as in the form of a sine wave or cosine wave, you will study in later what is the sine wave and cosine wave and all. So if this is a sine wave, then this will be the amplitude, that is the maximum displacement from the mean position is called the amplitude. So as far as amplitude is concerned, its dimension will be also the dimension of a length. So I can write the equation. The first, the LHS, dimension of the LHS will be L only, which is equal to which must be equal to the dimension of RHS. So dimension of A is L, then the dimension of sine of the angle within the bracket. So as you know, the dimension of angle is a 0, no dimension. It is a dimensionless quantity. So I can write L equal to L. That means equation 1 is the correct statement. Now let me discuss the second part, that is y equal to a sine vt. A sine vt. So here also you know that a is the amplitude and y is the displacement. Both will have the same dimension, and sine vt does not have any dimension, so this can be avoided. So this equation 2 is also the correct representation. Next, let me write the third relation, that is y equal to a divided by t times sine of t divided by a. So here the dimension of y will be L and the dimension of a will be amplitude, which is L, and the dimension of t will be t itself. And you know sine does not have any dimension, it will be 1. I am writing like this. So L equal to L divided by t. So that is not correct. So equation 3 will be ruled out. That means that is not the correct formula. Now let me consider the fourth expression. My fourth expression is y equal to a root 2 into sine of some angle is also written. I am not writing because you know that the angle does not have any dimension. I am not repeating it again. So here root 2 is also a constant which does not have any dimension. The dimension of y equal to L and the dimension of a is equal to also equal to L. So L equal to L. So dimensions of LHS and RHS are the correct. So equation 4 is also the correct expression. So from this analysis, equation 1, equation 2 and equation 4 will be the correct expression, and equation 3 will not be a correct mathematical expression. Okay students, let me discuss another question. Given that the amplitude of a scattered light is directly proportional to that of incident light, directly proportional to the volume of the scattering dust particle, and inversely proportional to its distance from the scattering particle, and depend upon the wavelength lambda of the light, show that the intensity of the scattered light varies as 1 by lambda raised to 4. So this is also a very easy question. Let me write the given data. So first of all, the amplitude of the scattered light. So I am writing amplitude as A. That is amplitude A of the scattered particle. I am writing AS, which is equal to a constant times, because in the question it is given proportional to. So I am just avoiding that proportional to by including a proportionality constant. So AS is equal to K times the first point is directly proportional to that of the incident light. It meaning is directly proportional to the amplitude of the incident light. So for amplitude I have already taken A, and AS is for amplitude of the scattered light. So here AI I am writing as a amplitude of the incident light. Now second point is directly proportional to its volume of the scattering dust particle. So anyway it is simply the volume. So volume directly proportional to the amplitude of the scattered particle. So I am writing AS equal to V. Now the third point is inversely proportional to its distance from the scattering particle. So inversely proportional. So I am writing 1 by of x. So this is the mathematical expression of the question. Okay, so as per the steps of dimension, I am writing the above equation as AS equal to K times AI raised to A, then V raised to B, and x raised to minus 1. So minus 1 raised to C I am writing, because it is 1 by x. So x will be going to a numerator, so it will be x raised to minus 1, and x raised to minus 1, the whole raised to C will be x raised to minus C. It's very simple. And lambda raised to D I am writing. So we have powers of A, V, X and lambda as A, B, C and D respectively. Now what I am going to do is just writing the dimensions of LHS and RHS. So AS is a amplitude, so amplitude has a dimension L. So L equal to K times the dimension of AI is also L. So L raised to A into dimension of V is volume, that means L cube. So L raised to 3B I can write. Next X is displacement or distance, it has a dimension L. So L raised to minus C will be coming. Next lambda is a wavelength. So wavelength and its dimension will be L, because length, simple thing. Now what I am going to do is I am just going to compare the powers of the similar terms of LHS and RHS. So before that let me rewrite the above equation. K times L raised to A into L raised to 3B into L raised to minus C into L raised to D I have. So I am writing L raised to A plus 3B minus C plus D. Okay. Now from the expressions or from the question 1, 2 and 3 points, it is clear that A equal to B equal to C equal to 1, because it is given in the first point directly proportional. So I can substitute in the above equation. So my answer will be coming like this. So K times A is 1 plus 3 into 1 minus c is also 1 plus d will be coming. That is the power of L, so which is equal to k times L raised to, this will be coming 1 plus 3 minus 1 plus d, that is 3 plus d. So L equal to k times L raised to 3 plus d will be coming. Minus 1 plus 1 cancelled. Now from this equation, I am just comparing the power of L from LHS and RHS. The power of LHS is 1 and power of L from the RHS will be 3 plus d. So 1 equal to 3 plus d, therefore d is equal to 1 minus 3, which is equal to minus 2. So power of lambda will be minus 2, I am writing. So let me substitute the power of A, B, C and D in this equation. That is equation number 1 I am going to substitute. So AS will be AS equal to k times what is our equation? AI raised to 1 V raised to B. AI raised to 1 B raised to 1 V raised to 1, sorry, this is V raised to 1 into x raised to minus c, that is x raised to minus 1, x raised to minus 1 into lambda raised to minus 2. I have lambda raised to minus 2. So I am just rearranging all these equations. So AS equal to k times AI, then V by x into lambda raised to minus 2, that I can write it as 1 by lambda square, I can write 1 by lambda square. So these all are some constant along with k. So I am taking this as a constant. So what I can write, AS equal to, in general, a constant, another constant into 1 by lambda square. Now as I told you from the beginning, intensity of wave will be always the square of the amplitude. Remember this one. Intensity of wave is square of the amplitude. So I will be writing square of the last equation which I have taken. So which will be AS square equal to, okay, k square will be again a constant. So I am writing k into 1 by lambda square, the whole square will become. That is AS is square of amplitude. So square of amplitude is intensity. So which is intensity of the scattered wave is equal to k times 1 by lambda square is 1 by lambda raised to 4. So IS is directly proportional to 1 by lambda raised to 4. So this was our question. I hope you understood. Okay students, let me discuss my another question. Let me read the question. The number of particles crossing per unit area perpendicular to x-axis in unit time, capital letter N is given by N is equal to, I am writing that N equal to minus D times N2 minus N1 divided by x2 minus x1, where N1 and N2 are the number of particles per unit volume at x1 and x2 respectively. Deduce the dimensional formula for D. So the question is looking like very complicated, but we can solve it very easily. Okay, so first of all let me rearrange this equation by writing N equal to minus D times N2 minus N1 divided by x2 minus x1. So we want to find the dimensional formula of D. So D equal to n times x2 minus x1 divided by n2 minus n1 minus just a cross multiplied. Okay, so this is the first equation. Now first of all, the number of particles crossing per unit area perpendicular to x-axis in unit time n is given by. So n is the number of particles crossing per unit area perpendicular to x-axis in unit time. So dimension of n can be written as number of particles crossing per unit area. So area has a dimension of L square and per unit time, so it will be T. So I can write this as L raised to minus 2 T raised to minus 1 as the dimension of n. Now dimension of small letter n2 and n1, which we have to iterate from the question. That is, from the question it is clear that n1 and n2 are the number of particles per unit volume. So dimension of n1 will be equal to the dimension of n2, which is actually the number of particles crossing per unit volume. So volume has a dimension of v cube, L cube. So I can write it as L cube as the dimension. Now we want to find the dimension of n1 and n2. So from the question it is clear that where n1 and n2 are the number of particles per unit volume. So it is per unit volume. So n1 and n2 will be same. Means dimension of n1 and n2 will be same, which is equal to 1 by volume. So which is equal to 1 by L cube. That means L raised to minus 3. That is the dimension of n1 and n2. Now the third part is, since x1 and x2 will be also having the same dimension, so which will be, I am writing x1, dimension of x1 and dimension of x2 will be equal to the dimension of length. So I can write it as L. So let me substitute the dimensions of capital letter N, small letter n1 and n2 and x1s in equation 1. So my answer will be the dimension for D. So that I can write it as L raised to minus 2 T raised to minus 1. This is the dimension of n into the dimension of we want to write the dimension of x2 minus x1. So x2 and x1 both are having the same dimension, which will be L. Now divided by n2 minus n1. So dimension of n1 and n2 is L raised to minus 3. That also we have done. So that will be L raised to minus 3. So our final equation will be, finally the equation will be like this: L raised to minus 2 T raised to minus 1 L into L raised to minus 3 will be going up to L raised to plus 3. So L raised to plus 3 and L raised to minus 2 will be cancelled to L raised to plus 1, and that L raised to plus 1 and this 1 will be L raised to plus 2, that is L square. So final equation will be L square T raised to minus 1 will be the dimension of D. I hope you understood this problem also.